All right, in this lesson, we're going to talk about section 12.2. Now, section 12.2 is arithmetic sequences. Now, assuming you took an Algebra 2 course, this is going to look very similar to what you saw in your Algebra 2 class. Foundationally, there's nothing different between what's going to be presented in this lesson and what was presented in your Algebra 2 arithmetic sequences lesson. All right? So we're going to start, now just for a quick review, we'll start with a review here. Remember, a sequence is a function. That's the most important thing for us to remember. A sequence is a function. It comes with a different set or a different notation than our normal function notation, f of x, but a sequence is just a function whose domain is the positive integers. Right? So what are we working with here? We're working with functions, just like we have been for the entire course. We're working with functions, and we're working with functions that have a nice domain. The domain of our function, right? The domain is the set of positive integers. That's the domain of our function. So, today in 12.2, we're going to learn about a specific kind of sequence, a sequence that follows a certain characteristic. So we'll begin with the definition. What does it mean for a sequence to be arithmetic? So the defense, that's a different lecture for a different time. The definition says, in arithmetic, sequence may be defined recursively. May be defined recursively as, right, a sub 1 equals a. Remember how recursive sequences work. We're given usually the first term. In this case, we're given a sub 1 equals a. And then we're told a sub n is minus a sub n minus 1 equals d. Now what does that say? That says if I have a term, say n is 3. If I have a term such as, well, here, we'll write something below here. We'll say, what does this say? This says a3 minus a2, right? N is 3, so 3 minus 1 is going to be 2. My third term minus my second term is going to be d. But it doesn't work for just 3. It works for 4. My fourth term, n is 4, minus my third term is equal to d. In fact, it works for, example, the 27th term. My 27th term, now n is 27, minus my 26th term is still equal to the same number, d. So what are they trying to tell us? What is the point that you're trying to get us to realize here with this definition? They're trying to get us to realize that whatever our first term is, we don't care, right? Notice there's nothing over here about a. We don't care what our first term is. What's important to us is that the difference between each term is d. If I take a term minus the term prior to that, I take my third term minus the term that came before that one. Through the third term minus the second term, I get D. Fourth term minus third term, I get D. 27th term minus 26th term, I get D. And this is true for any two continuous terms. That's our recursive definition. Now, another way we could have written that, right? Another way we could have written that. Our author says, or as, we could have said this. We could have said our first term is A. Now, that's just going to be a number, like your first term is 6 or 12 or -8. Whatever it's going to be, your first term is just a constant A. Then, the next term is the previous term plus the common difference. All right? If we look back here at our definition, all we've done here in our clarification step, right? Or as is supposed to be a clarification step. It's supposed to make it better. All we've done is we've moved the A sub n minus 1 to the other side. It was negative on the left. It's going to be positive on the right. And so they're telling us our fourth term is our third term plus D. Our 27th term is our 26th term plus D. All right? That's an alternative way of looking at it. This is most often the form we use. Okay. Most often, that's the form we use, that form right there, versus this form up here. Now, the definition finishes with where A sub 1 equals A, and D are real numbers. It goes on in the book to just define for us the name of each of these. This says A sub 1 equals A. So your author says, he says, the number A is called the first term. All right, now that doesn't come as a big shock to anybody, right? The number A is called the first term. And the number D is called the common difference. Okay. So, this is our definition. All right, this is our definition. If we just try to list our terms, right? Now remember what we said. We said our first term is A. And we said our next term, if I make this a 2, right? I'm going to write A sub 2 here. If I make this a 2, our next term is our 2 minus first term. 2 minus 1, 2 minus 1 is 1. So that's going to be my first term plus my common difference. Now, if we rewrite that, since we know what our first term is just an A. That's just a number. So our second term is A plus D. Now, what about our third term? Maybe we can see a pattern here, right? Our third term, now this is a 3. This is going to be 3 minus 1. That's going to be 2. So that's going to be my second term plus D plus D. But I know what my second term is. My second term is A plus D. Now I have another D. And what do we get? We get A plus 2 Ds. If we do this one more time, I think we're going to see a pattern here, aren't we? A sub 4, now this is a 4. That's going to be 4 minus 1. That's going to be a sub 3 plus d. But we know what a sub 3 is from up above. A sub 3 is a plus 2d plus our d gives us a plus 3d. And from here, perhaps we can start picking up a bit of a pattern. I think we can probably take a really good guess at what the fifth term is. After all, the fourth term had 3 d's. The third term, 2 d's. The second term, 1 d. The first term, 0 d's. So 1 gave us 0, 2 gave us 1, 3 gave us 2, 4 gives us 3, so 5 probably gives us, and you're 100% correct, it gives us 4. And from here, we can write down what the general term is going to be, right? This is a recursive definition up here. Up here, if I want to know the nth term, I have to know the term prior to that. The term prior to that. Well, maybe if we use what we've written in blue here, we can come up with a way to shortcut that. So we don't have to. If I want to know the 27th term, maybe I don't want to have to find the 26th term. Because to find the 26th term, I've got to find the 25th term. And then to find the 25th, that's a lot of work. Maybe we can see a pattern here. If this is a 5, I get an A. If this is a 4, I get an A. If this is a 3, I get an A. If this is a 2, I get an A. If this is a 1, I get an A. Everybody gets an A. Well, if this is a 5, I get a 4. If this is 4, I get 3. 3, I get 2, etc. So this is an N. I get 1 less than that. And I multiply this by D. Now, hopefully this is ringing a bell from what you did back in Algebra 2. Remember, you covered all of this in Algebra 2. All of this, right? So this is what we mean by an arithmetic sequence. An arithmetic sequence, all right? So that's our definition. From there, we can start covering our learning objectives. So, what am I going to do here? I'm going to clean this off, all right? I'll clean this off. I'm not going to clean all of it off. What I'm going to do is I'll just take care of this bottom part down here. That'll leave us some room to do our work in underneath here. And we'll keep the important part, the definition, up above. Okay? So what's our first learning objective? Our first learning objective says we want to determine if a sequence is arithmetic. Right? That's what we want to know. Is this an example of an arithmetic sequence, or is this not an example of an arithmetic sequence? If I write an example down, something like, something like 0, 3, 6, 9, 12, etc. My task is to explain to you how am I going to determine if that's arithmetic or if it's not arithmetic. And what do we focus on? Well, we focus on the definition. The definition says we are going to have a common difference. A common difference. And we had a little table we set up right here. So what could we do? We could see if each of our terms is separated by a common difference. How far is it from 0 to 3? Well, we added 3. How far is it from 3 to 6? Once again, we added 3. How far is it from 6 to 9? We added 3. And how about 9 to 12? We added 3. So, assuming that this dot, dot, dot means that everybody follows the same pattern, which is what it does mean, we have a common difference of 3. What's our first term, right? Because remember, our first term is A. A is our first term. A sub 1 is our first term. So here, A sub 1 is 0. A sub 1 is 0. So we have found our common difference. Our common difference, we checked. We made a list. Well, we were given a list. And we just checked to see which terms, how far is it from 0 to 3, 3 to 6, 6 to 9, 9 to 12. Okay? Now, what happens if instead of doing that, though, they tell us something like your sequence, right? They give us the general term. Our sequence is 2n plus 3. Okay, I just made that example up. How would we tell if this is arithmetic? Well, what are we going to do? We're going to find the first term, and the second term, and the third term, and the fourth term, and we're going to see if there's a pattern. Is there a pattern that has a common difference? So what's our first term? We did this back in 12.1, right? First term is A sub 1. We put a 1 here for n, so we put a 1 here. We'll write that out. It's 2 times 1 plus 3. That's going to be 5, isn't it? And again, most of the time you do this in your head. A sub 2. We're going to put a 2 here, so we're going to put a 2 here. That's 2 times 2 plus 3. That's 4 plus 3, that's 7. Right? Now, we can't stop right here and say, oh, I've got a common difference. We don't have enough terms. All we know is these two differ by 2. So what's A sub 3 going to be? Well, A sub 3, right? A sub 3 is going to be 2 times 3 plus 3. That's 6 plus 3, that's 9. It's looking pretty good right now. If we try one more, A sub 4, right? A sub 4. What's A sub 4 going to be? Well, A sub 4 is going to be 2 times 4 plus 3. That's 8 plus 3, that's 11. Now, I see and you see that this is plus 2, this is plus 2, and this is plus 2. And back in maybe our Algebra 2 class, maybe in Algebra 2 our teacher would say, okay, you've shown me there's a common difference. This isn't Algebra 2 though, is it? It's just not. It's not Algebra 2. What are we going to be asked to do to show? Well, we did this step. This step is required. It's a great step. It leads us to believe this is arithmetic. But where do we go from here? Well, we've got to add a little more formality to this solution. What we're going to ask ourselves is, we're going to ask ourselves, because the definition clearly states right here, right? It clearly states that if I take the nth term minus the term prior to that, I'm supposed to get my common difference. So I'm going to check, right? I'm going to check my definition. We can't just write down 4 terms and say it works for every number. Every positive integer, we plug in 1, 2, 3, 4. There's still an awful lot of positive integers available, so we need to check our definition. Now, what are we going to do? We're going to write down the nth term. That's what our definition asks for. Now, we know what the nth term is. We have an n here, so it's going to be 2n plus 3. So we've written the nth term. We're checking the definition. Now we have to write the n minus first term. Now, don't be overpowered by this. You know what to do here. This is n minus 1, right? When it was a 3, you plugged in a 3. When it was a 2, you plugged in it was 2. When it was 4, you plugged in 4. When it's n minus 1, you just plug in n minus 1. Don't overthink it. Don't try to make it complicated. Now, we know what that is, don't we? That's 2n minus, that's 2n minus 2 plus 3, isn't it? And if we simplify that, that's 2n plus 1. So what have we done? We're checking our definition. We've plugged in the formula for the nth term. We've plugged in the formula for the n minus first term. Now we're going to check. We're going to check to see if when we subtract them, right? When we subtract them, what do we get? Well, we get 2n plus 3 minus 2n, right, from here, minus 1. 2n minus 2n is 0. 3 minus 1 is 2. There's our common difference. We can't do this. We might have been able to do this in an Algebra 2 class, but in a pre-calculus class, we're expected to go beyond just numerical justification. We need to use the definition and show its arithmetic in this manner. All right? So that's our first learning objective. Let's move on to our second learning objective. So before we can get to that, I'm going to need to erase. Let me erase this. Now the good news is there's only 2 learning objectives in this section. 2 more learning objectives in this section. There's only 3 learning objectives. Okay. So where do we go from here? Well, we're going to pick up learning objective number 2. Learning objective number 2 says we want to find a formula for an arithmetic sequence. Find a formula for an arithmetic sequence. And they want us to actually find the formula. Now, you and I, we've kind of already done this, to be perfectly honest with you. We did this in our introduction video. Not introduction video, but in our introduction example. In the textbook, they point out to us that the first term is A, and then they construct what you and I have already constructed. They tell us, well, the second term is going to be the first term plus the common difference, which for us is A plus D, right? We've already done this. I'm not going to explain all these steps again. We'll write it out again. It's good to have it in our notes more than once. Hopefully you're taking notes as you watch these videos. If you're not taking notes while you watch the videos, it's supposed to look like school, guys. You should be taking notes. So what is a sub 3? A sub 3 is a sub 2 plus a common difference. It's the term we had before plus the common difference, but we know a sub 2 is a plus d. So that's going to be a plus d. That's a sub 2 plus our d, a plus 2d. A sub 4 then is going to be a sub 3, right? That's part of our definition. It's the previous term plus d, but we know the previous term is a plus 2d plus our d from this term, and we're left with our a plus 3d. And from there, right, just a couple of minutes ago in the video, from there we said, all right, it follows then that our nth term is going to be our n minus first term, the one that came before it. 4, the one that comes before it is 3. 3, the one that comes before it is 2, plus d. Now, what does that mean? Well, that's our definition, right? That's our definition. We have that down in our notes already. But we know we know from here, we can see what the formula is. It's a plus 0d, a plus 1d. So 2 gets us 1d. 3 gets us 2d's. 4 gets us 3d's. So n, right, n gets us a plus n minus 1d's. And that is the nth term formula, right? That's our formula for the nth term of an arithmetic sequence. All right? Now, what do they want us to do with that? Well, what do they expect from us here? They expect us to find a specific or a particular term, right? In our previous example, we had an arithmetic sequence that started 0, 3, 6, 9, 12, and it just went on and on and on. So what might they ask us? They might give us a sequence such as this one, right? They give us a sequence such as this one, and they'd say, find the 37th term. Now, they could use words, right? They could do that. They could say, find the 37th term, or perhaps they might say, find a sub 37. Either way, it's our responsibility to realize they don't expect us to write out this 37 terms. They don't want that. On the test, that's not what we're looking for. We're looking for you to use this formula right here. What do we know the 37th term is? Well, the recursive version of the definition says, right, if we look over here, if we look here, we determined earlier that D was 3 for us, didn't we? So the recursive definition says, I'm going to take the 36th term, the one that comes before this one, and I'm going to add 3. Well, unfortunately, we don't know the 36th term. So that's true, but it's not the answer anyone's looking for. Again, our options are not to go 0, 3, 6, 9, 12, 15, 18, and count out 37 terms. Nor is it possible for us to say the 37th term is the 36th term plus 3 more, because our common difference is 3. That's also not what we're expecting. We're expecting you to use this formula right here. We're expecting you to say, hey, I know what the 37th term is. The 37th term is the first term, plus 37 is n. N is 37, plus 37 minus 1 times my common difference. And then we want you to plug in the values of those. You can see them here. Your first term is 0. We all know 37 minus 1 is 36. And then our common difference is 3, right? So what does that work out to be? That's 3 times 30 plus 6, right? Because 36 is 30 plus 6. 3 times 30, we know what 3 times 30 is. That's 90, right? That's 90. And 3 times 6 is 18, so we get 108. So that's our expectation. Our expectation is that we're going to use this formula to find these terms, right? Now, what else can they do to us here? What are some of the other kinds of questions that they can give us? Well, they can give us this kind, right, where they ask us to find a certain term. But then there's another kind of question they could say. They could say something like this. They could say, here's another example. They could say, well, a sub 12 is 4. Okay, so your fourth term is 12. Sorry, other way around. Your 12th term is 4. And then they could say your 18th term is 28. Now these problems are in your Algebra 2 book. Problems just like this. You do problems just like this in Algebra 2. What are we supposed to do here? How are we supposed to figure out? What do they want us to do? They want us to find, right? They want us to find A, D, and A sub n's formula. Now this is a very common quiz or test question. How am I going to find the common difference? How am I going to find the beginning? I'm not at the beginning. I'm starting 12 terms in and 18 terms in. Well, we're going to use the formula that we were given right here. Right? That's the secret to doing these kinds of problems. Look, we know 4 is a sub 12. But we know what a sub 12 is. A sub 12 is our starting term. Now, we don't know what that is, so I'm going to call that A plus, And I'll go ahead and fill this in as 12 minus 1, just so our notes look complete. It's really 11, right? But we're going to fill in as 12 minus 1, n minus 1, times our common difference, d. Now, we don't know what that is either. Now, we can simplify this, can't we? This is a plus 11d's. That's what that is. Now, we're going to do the same thing for this. We know 28 is equal to our 18th term. Now, I don't know what my 18th term is, other than it's 28. I don't know how to write it in this format, but I do know it's my first term plus 18 minus 1 times d. Now, if we simplify that, that turns out to be a plus 17d's. All right. Now, as it's written right here in red, it may not look very familiar to us. But if we write it in blue, like this, look what this says. This says a plus 11d's is 4. And down here it says a plus 17d's is 28. And if I put a bracket around this and a bracket around this, doesn't that look familiar? That's a system of 2 equations and 2 unknowns. We know how to work that out. We know what to do with that, right? We learned how to handle that. In Algebra 1, we learned, what do we want to do? Let's use the method of elimination. That's the best one anyway. Let's make this a minus, we'll make this a minus, we'll make this a minus, and we'll add these up. What are we going to get? We're going to get 0 here, right? Remember, method of elimination, you want to eliminate a variable. Here we have negative 11 plus 17. That's going to be 6d's. Here we have negative 4 plus 28. That's going to be 24. And d equals 4. Remember, we're supposed to find a, find d. We've got d. D is 4. Right? So we're a third of the way done with the problem. Now, what else do we need? We need a. Where can we go to find a? Well, we can use either of these 2 formulas. Right? We have a formula right here, and we have a formula right here. Or we could use the blue ones. They're the same formulas. So which one am I going to use? I'm going to use this one because I don't want to take 17 times 4. I would much rather do 44, right? 11 times 4. So I'm going to use that formula. That formula says 4 is equal to a plus 11 times d, but d is 4. So that's going to be a plus 44, right? So what do we add to 44 to get 4? Or you move the 44 over here, and you're going to get a equals negative 40. And now we found a. Now the last thing they asked us to do, right? The last thing they asked us to do is to give them the formula. Give them the formula for a sub n. Well, we know what the formula for a sub n. It's written right here. Here's the formula for a sub n. So we know a sub n is equal to a, and you and I found a to be negative 40, plus n minus 1 times d, and our d turned out to be 4. So if we simplify this, right, if we simplify this, what do we get? We get a sub n equals negative 40. 4 times n is 4n. 4 times negative 4 is negative 4. And so we get, when we add this together, we get 4n minus 44. And that's our expression for a sub n. And we found all 3 parts. Okay? So that was our second learning objective. Now for our third learning objective. All right, so I'm going to erase this. I know what I'm going to do when I run out of this spray. So now we'll take care of our third learning objective. Now our third learning objective says, find the sum of an arithmetic sequence. And if all this looks familiar, it's because, again, remember, you did this in Algebra 2. Find the sum of an arithmetic sequence. All right, we want to find the sum. Now, what does that mean? Well, if we let a sub n, right? That's a sequence, right? That's a function. Don't forget that. That's a function. If we let a sub n be an arithmetic sequence, with a sub 1 equaling a and a common difference of d, then what do we know? Well, we can write down the sum, all right? Now, where is the sum going to come from? What is the sum going to look like? Well, first of all, it needs to be pointed out that we're only finding a finite sum. A finite sum. We're finding s sub n. This means the sum of the first n terms. If some of you are thinking, oh, I remember last year we found the sum of an infinite number of terms, that's because last year, you were thinking about a different type of sequence. You were thinking about a sequence that was called a geometric sequence, right? A geometric sequence. So, what do we know s sub n is equal to? Well, we know s sub n is a1, right, plus a2 plus a3 plus all the way to a sub n. Right? Isn't that what we know? I think that's true. And we know what that is. We know a1 is a. And I'm going to write it like this. I'm going to write plus 0d, because we're going to do something that's kind of interesting here. It's kind of fun. My first term is a plus no d's, right? What's my second term? My second term is a plus 1d, isn't it? Isn't that what my second term is? A plus 1d. My third term, right? My third term is a plus 2d's. Now, we didn't write a sub 4 here, but let's just go ahead and put it here. That's going to be a plus 3d's. And if we add all these up, my last term, right? My last term, we said that was going to be a plus n minus 1d's. That's what we said, right? Well, who comes before that? Before that is a plus n minus 2d's. Now, that's everybody laid out. Now, why did I do that? Well, I'm going to write them again. It was so much fun to do it the first time. I'm going to do it again. This time, though, I'm going to flip them around. Instead of writing the first term first, I'm going to write the last term first. And instead of writing the second term second, I'm going to write the second to the last term second. So we're just going to copy this down again right here, because it's the same sum, but we're going to flip it. All right, so what's that going to look like? Well, right here we're going to have a plus n minus 1d, right? That's this term here written down there. Who comes second? Well, this term comes second, doesn't it? That's going to be a plus n minus 2d's. Now, the term that came before this one, right? We didn't write it. But the term that came before this one was a plus n minus 3d's. I promise this is going to turn out to be pretty neat, so just be patient. Now, who goes under here? Well, the first term. which is a plus 0d's. Right? That's what we said that one was. And who goes here? The second term. That's a plus 1d. I'll go ahead and put the 1 in front. All right? Now, what are we going to do? I mean, what crazy thing have I got going on here? Well, let's just take a look and see what happens. Let's add this side together. We get our sum plus our sum again. That's 2 times our sum. Right? That's 2 times our sum. What happens when we add these together? Well, let's take a look. I'm just going to add straight down. Right? I'm going to add straight down like this. Let's see if we can do that without messing it up. That's going to be a plus a. That's going to be 2a. Sorry, didn't mean to stop. Got to plug my computer in. All right. So, a plus a is 2a's. 0d's plus n minus 1d's turns out to be n minus 1d's, doesn't it? Now let's see what happens when we add these together. We have a plus a. I'm going to put parentheses around this. I'm going to go a plus a. Well, you know what? That turns out to be 2a's. And then I'm going to go d, right? D plus n minus 2d's. Now that's 1d right there. So 1 plus n minus 2, well, that turns out to be n minus 1 again. N minus 1 d's. What happens over here? Well, we have a plus a. You know that gives us 2a's? Now I have 2 plus negative 3. That turns out to be a negative 1d. N minus 1d. And you're right. That term, and that term are all the same. In fact, if we continue this little game all the way to the end, what happens here? We get a plus a. That's 2a. We get n minus 2 plus 1. N minus 2 plus 1 turns out to be n minus 1 d's. And all of these terms are exactly the same. Here we get 2a's again. N minus 1 plus 0 is going to be n minus 1 times d. Every one of these terms turns out to be identical. They all turn out to be exactly the same. Now, what does that cause, right? What happens? Well, if we add them up, how many of them are there? Well, how many terms are there in our sum? 1, 2, 3, and it goes on until we get to n of them. So we have n of these added up. So what does that say? That says 2 s sub n, right, is n of these things. And if a little bit of recognition is starting to come your way, it's because you've seen this formula before. Because now we have the formula for our sum. Look, s sub n equals, we divide both sides by 2. N divided by 2 times 2a plus n minus 1 times d. That's the formula that in Algebra 2 you memorized for the sum of an arithmetic sequence. This is the formula for the sum of an arithmetic sequence. Now, if you're sitting down to take a test and you forget the formula, worst case scenario, you could just do this little trick to find the formula. Right? It's not that complicated of a development. The derivation of this formula is not that hard. Now, if we take a look at our book, this formula is in the book, right? It's in the book, it's in a box, it's one of those formulas we're supposed to know, but there's another way. They write this another way. Now, let's take a look at what we have here. I'm going to take these 2a's, and I'm going to write this It's very complicated math. I'm going to write 2a as a plus a. Now, I'm going to ask you to look back in your notes. Look back in your notes. Or look right here on the whiteboard. What did we decide the nth term was? Right? Back in our notes, we said this. We have this written in our notes. We know what the nth term is. The nth term is a plus n minus 1 times d. Well, look right here. A plus n minus 1 times d. So in our book, we have another way to write this. We write it as a plus a sub n. And then they point out to us that a is the first term. So there are two of these formulas, right? There's this one, this version here, and this version here. And we should be able to switch back and forth. Now the question is, which one do you use? Well, you use whichever one fits the givens from the problem. So what does a typical problem look like that utilizes this, right? Learning objective 3, find the sum of an arithmetic series. What do they expect us to do? We have the formulas. Now we have to know these formulas. We have to have these formulas down. We have to have them memorized. We've got to understand them. If you're taking a class where the teacher like me, for example, would expect you to develop this on a test, then you're going to have to remember on the exam how to get from here through this whole development and get down to here. Now, I don't know what your teacher expects. I always put this on the test as a required problem because the problem with memorizing formulas like these is we forget them. I mean, after all, you learned these last year in Algebra 2, and whether you remembered them or not, who knows, right? So my students always have to develop this. In case my students are listening and they don't take hints very well, you're going to have to do this on the test, all right? Now, I don't know about anyone else's teachers, but that's what happens in my classroom. So how do we use this to solve a problem? What's a typical problem look like? Well, a typical problem they give us is something like this, right? It says, what is, I'll just do the example right here. We'll work it out right down here. The example would be something like this problem right here. 2 plus 5 plus 8 plus, and it keeps going until it gets to 41. And it says, find the sum. Find the sum, right? That's all it says. Now, how are we going to do that? Well, we're going to have to use these formulas. And which formula we choose is based on what we're given. What do we know right now? We know our first term, right? We know our first term is 2. We know our last term, right? Our last term is 41. So if you're thinking, okay, I know my first term is 2. I know my last term is 41. We also know what our common difference is, don't we? We know to get from 2 to 5 or 5 to 8. We know our common difference is 3. So if we start checking things off, we know our first term, right? So that's there. And it's also, in our formula right here. It's right here, right? That's A. We know A is 2. Now we know our common difference is 3. In this formula, we need that. Down here, we don't. We know our last term is 41. Down here, we need that. Up here, we don't. And if you'll notice, there's one glaring hole in both of these formulas that we don't know. We have no idea how many terms this is. Now, this is very typical for one of these types of problems. We don't know how many terms. Now, they don't expect us, right? They don't expect us to go, okay, 2, 5, 8, 11, 14, 17, 20. If this is what we're going to do, then how is our teacher going to combat that? They're going to make this last term over here 4,306,000. And now you don't have enough time during the test to count. So typically with these problems, when it says find the sum, we must find n. All right? Very typical for these problems. How are we going to do that? We're going to use this formula right here. We're going to use that formula right there to find n. We know that our last term is 41. we know our last term is a, 2, plus n minus 1. We don't know n, so we don't know what that is. N minus 1 times d, and we know d is 3. And we can solve this, right? We get 2. 3 times n is 3n. 3 times negative 1 is minus 3. And remember, this is 41. So what does this equal? This equals 3n, right? 3n minus 1. Now, if we bring the negative 1 over here, we get 42 equals 3n, and that gets me n equals, right? 3 goes into 4 once, a remainder of 1. 3 goes into 12, 14. So n is 14. Now, why did we need that? Well, because if we go back to our formulas, we needed it here and here in this version of the formula, and we needed it here in this version of the formula. Now, which version do you use? Whichever one you like the best. In this case, since we knew the last term, we could use this version, right? What would we get for our answer? We'll just work it out right here. What would we get? We would get n. We said n was 14, so that's going to be 14 divided by 2. And then we get the first term. We said our first term was 2. Our last term is 41, isn't it? 41. So what do we get? We get 14 divided by 2. That's 7. 2 plus 42 is 43, right? 43. And you've seen me do this multiplication many times now. This is 40 plus 3. So 7 times 40, right? 7 times 40 is 280. 7 times 3 is 21. And what do we end up with? 301 as our answer. All right? So that is a very, very typical problem when we're asked to find a sum. All right, so that's the lesson on 12.2. And I have done problems that are very, very similar to the problems that are in the homework. I've done problems that are very, very similar to the examples in the book. And so if you use this video along with reading the book and following the examples, you should be able to complete your homework assignment in 12.2. All right, everybody have a great evening. It's evening, by the way, here.